This is Sharika, UR14CS122. This is experiment 6 in compiler. This is in assembler. So here first we import all the necessary files for the buffer reader, writer, the hash table and the exception. And then in the program here we have hash table opcode ready op table. This is for we are declaring the opcode table, and then this is for the symbol table. And then buffer reader, we are reading from the file program.txt, and then buffer writer, we write it into inter.txt, that is the intermediate code. And then here string line title, we declare it as null, and then lc is initialized as 0 and start is initialized as 0. And then here we read, and when we read from the from the file program.txt, and when we encounter start, we increment the location counter. And then if the start is equal to 0, then the location counter also points to start. And then when we encounter end, we increment the location counter. We write by all the line, opcode, symbol table, lc, wr. And then when we do int length equal to calculate the length of the program, we do location, the value of the location counter minus start. We get the length of the program. And then here now from now we read from the intermediate file, that is from using buffer reader. And then when we encounter start, we print it as the header. H stands for the header record. So H, the caret symbol, the title of the program is printed. And then 26 integer or 2 hex 6 is to convert into the corresponding hexadecimal representation. And this is the program name, the program starting address, and this is the length of the program. And then if it contains end, then we print it as E, the caret symbol, and then the starting address of the program. And then else we increment the location counter. And then here, and so in the second pass we read the text record. So the text record, when we encounter T, we print it as T, and then we do the respective hexadecimal conversion. And then this is location count, and we increment the address by 3. And then in the opcode, the opcode and the symbol table, we append the opcode in the symbol table, and it is written as the object code. And then if we encounter any reserved word, then the location counter is incremented by 3, and if it's a reserved byte, then by 1. And if it is a the reserved word, the respective integer value, the reserved byte also the respective thing accordingly. Only word it is fixed, it's 3, and if it is a byte, it's 1. And then now we check if if the symbol table is properly updated. If the symbol table is not properly updated, we check for the proper updation of the symbol table, and then we check according to the split. And then if it contains, then we put it in the symbol table. And then if the label already exists, then we don't mind. We don't do anything. And then if it is invalid symbol, we print it as an invalid symbol. The same thing, if it is a word, we increment it by 3. If it's a reserved word, based on its respective integer thing, and then even reserved byte is like that. And then finally here we print the object, we read from the opcode table, and then we get our object code. So let's see the output. So this is the output of our this is our object code. First we have H, the header, and then the name of the label, copy, name of the program, and this is the starting address, and this is the length of the program. And then the text, again we have incremented by 3, C 4000, 4003, 4006, and so on. And this is the opcode. And then E, this is the end of the file. So let's see the inputs used for the program. This is object. So first this is our program.txt. We have the program here, and then this is our intermediate file, and this is the opcode. This is experiment 6.